of Financial at Central University of Punjab, and Sir is presently working in the Department of Financial Administration since 2018. And before this, Sir was associated with the Aligarh Muslim University, Aligarh, from where he did his MCom in the accounting and finance, and PhD also on the area of capital market. And beside this, Sir has also completed one project on the performance evaluation of the Indian mutual fund industry under the grant seed of University Grant Commission. Sir has in his credit a Best Teacher Award in the Central University of Punjab in the Feb 2020. And Sir has also received Best Paper Award in the International Conference organized by the Rajasthan Chamber of Commerce and Industry, Jaipur Management Association. And beside this, Sir has also credit in his favor fellowship from the UGC for the postdoctoral degree, and Sir has various conferences and international and national in his credit, and in those conferences Sir has presented his paper and also chaired the session of these conferences. And beside this, Sir has delivered invited lecture in counseling session on the preparation of CUET 2022. Sir has also delivered one lecture on the budget making process in the 3 days training program on the gender budgeting organized by the Mahatma Gandhi State Institute of Public Finance. Sir has also delivered an invited lecture on the series of relevance of MOOC in the social science in the 1 week national interdisciplinary workshop on contemporary issues and approaches in social science, delivered guest lecture on the topic contemporary development in the field of accounting in the G Institute of Management and Technology. Sir has also the co-convener of the 2-day ICSSR sponsored national webinar on the digitalization and sustainable business model and innovation in rural India. Sir has also coordinated the Atal-sponsored AICTC Faculty Development Program on the strategic planning and implementation in the digital area conducted by the Department of Financial Administration. Beside this, Sir is presently acting as a member of IQAC Central University of Punjab, member of Mentoring Cell, subject matter expert of the Tata Consultancy Services, reviewer of the InterScience Sage publication AIMS International Journal of Management. Sir is also acting as a member of school board of the department as well as Department of Applied Agriculture and Department of Economic Studies. Sir has also acted as a observer at a Jalandhar Center for the CUCET conduct exam. MOOC coordinator is in the category of the SERV, internship and placement coordinator, active volunteer in the national conference entitled Inclusive Development and Mainstreaming of the Minority Community in India, organized by the Department of Commerce, Aligarh Muslim University. Besides this, Sir is also guiding the national and international student for the PhD. Sir has approx 50 PG dissertation in his credit. And apart from this, I would like to end with just the thing that Sir has so many things in his credit. Only some I mentioned, some are being left. So now I request the Dr. Dhanraj Sharma sir to please carry out the session with your kind word. And now please over to you, sir. Thank you.
Very good evening to all of you. I hope that I'm audible.
Good evening, sir.
Good evening. So thank you, ma'am, for introducing myself. And I'm very grateful to the organizer of this International Faculty Development Program. And it is sponsored by, it is a joint effort of so many institutions and universities at India level and outside India also. So I am very thankful to the organizers. And we can see that the participants are there from different states of India and from different countries also. So it provides that this is a big success of this program. And just I'm going to share my screen with all of you. Just give me a message that whether it is visible or not. My screen is visible?
Yes, sir.
Okay, thank you. So today we are going to discuss about the data analysis in social science and humanities research. And if we talk about the research, so till now, I think you have already gone through so many various very important sessions in this International Faculty Development Program. And it started with the introductory aspect of the research. And I think you have already covered the research ethics also. So right now, we are going to discuss about the data analysis in the social science and the humanities research. So the very first thing is that we should know that what the research is all about. So anyone who can give me some idea that what the research is all about? Till now, what you learned about the research? So if we see this term research, so it is comprising two words, re and search. So it is a continuously search for something and that contribute for the research. In a general term, we can define this as a continuous search on any topic or continuous search to get any new knowledge or for making any addition in the existing branch of knowledge. So this is all about the research. And in terms of concept, you can define the research as, first of all, it is a systematized effort to gain new knowledge. Second, it is related to the original contribution to the existing stock of knowledge, making for its advancement. And third is the search of knowledge through objective and system of finding solution to a problem that is known as a research. If we see the recent National Education Policy, NEP 2020, so the major focus of the policy is towards the research. And that's why it is suggested in the NEP 2020 the curriculum document also and increase and provide the content which is related to the research. So in this, so we already implemented in our university that the fourth semester of the PG program, it is completely related with the research, and the students are given the chance for doing the research or dissertation. And the whole semester there is a no academic teaching. All the things are related with the research. So in the third semester, the students are doing their proposal. They are making their synopsis along with the other subject. And in the fourth semester, the complete research is there. Apart from that, the concept of research universities, it is also given in the NEP document, and the focus again is to enhance the research and to make searches on the various problematic issues. So again, you just see this line that the systematized effort to gain new knowledge. So if we talk about the research, so it is all about to gain the new knowledge, new concept, new theories, new innovation. This is also something which is related to research. Second thing that we are talking about the research is original contribution to the existing stock of knowledge. Whatever the concept that we are giving today as a part of innovation, the same cannot exist in the future because the circumstances will be changed, then the situation will be changed. So in this scenario, whatever the things which are prevailing today, whatever the things which are existing today, the same thing cannot prevail in the future. So generally there is a debate on the mechanism in the form of research, and that's why we are saying that the research is also related with the original contribution to the existing stock of knowledge for making its advancement. Third, it is all about objective, systematic method of finding solution to a problem is research. The focus of every research is to provide the solution to the problem. And if we see that there are so many problems, if we see from the angle of the corporate, if we see from the angle of the government, if we see from the angle of the society or anything, so you may find that there are so many problems. And even we can take the example of the COVID-19, the recent pandemic, which started in earliest 2020. So again, you can see that was a big disaster, that was a big pandemic, and through the research, we developed a vaccine, and whatever the severity was there, we were able to reduce that severity of the pandemic. So again, the involvement of research was there. So there was a problem, and on that basis, we did the research at in the various discipline, and again, we came with the various solution also related to that problem. So we can say that research is something through which we are going to provide the solution for the problem. The next thing is research process. So this lecture is all about the data analysis, but before this, we have to see that what the research process is all about. So when we are going to start any research, in the research, first of all, we are going to define the research problem, or you can say that the statement of problem. So as I already discussed with you that every research is based upon some problem, and generally we say this as a statement of problem or formulation of the for problem statement. So this is a very first step of the research, to define the research problem. Because there is a problem, that's why we are going to conduct a research, and through our research we are going to provide the solution of this problem. So the very first step is defining the research problem. If you want to do a good research, you should be aware about the research problem. Second thing is review concept, theories, and previous findings. So, and second step, which is related with the review of literature. And in the literature, you are going to review the concept also, which is related to your research topic. You are going to review the theories also, which are related to your topic. And you are going to see the previous finding also in the papers, in the researches, which were already published related to your topic. So this is something which is related with the review of literature. After the review literature, we are going to see that what is the research gap. Research gap means that how you are going to conduct a different study. Whatever the things which are not earlier covered in the previous studies. So review literature, first of all, you are going to review the concept, theories, and previous finding. At the same time, you are also going to provide the gap, that how you can differentiate your study from the earlier studies conducted. The very next thing is formulate hypothesis. So hypothesis, as you all are aware, that this is a tentative statement that we are going to test. And we have to frame our hypothesis in line with the objective. Okay, whatever the objective of research are there, on the basis of these objective, we need to formulate our hypothesis.
Recording.
So hypothesis, it is a tentative statement. It is a argument that we are going to test to check its existence. Then research design. So in the research design, you are going to provide the information that how you are going to design your research in the form of sample, that how you will get your sample. You need to give the sample profile also. At the same time, you need to provide the method of sampling. Various methods are there. Then you need to provide the sources of data also, whether you are going to collect the data from primary sources or secondary sources. And you are going to provide the information related to your variables also. If you are going to collect the data through the primary sources, that you need to provide the data, that which instrument you are going to use to collect the data, in the form of questionnaire or in the form of other things which are the source in the source of primary data, like schedule. Then variable description is there, the techniques that you are going to use. So all the things are there, which is a part of your research design. The more strong research design, the more strong is your research. It is, in other words, you can say that the strong research design is going to enhance the value of your research. Then collection of data is there. You will start collecting the data from the authentic sources. Okay, if it is a primary source, then definitely through the various instruments, you can collect the data in the form of questionnaire also, schedule also, interview also. And if your source of data is secondary, so you need to see that from the source you are going to collect the data, it should be authentic in nature. For example, in our field, if we are talking about the finance, so the bank related data, it is already available on the website of RBI. So there is a complete database, and from this you can collect the data which is related to bank. It is providing you the all financial information of the banks. At the same time, it is also going to provide you the status of NPA, non-performing asset, status of capital adequacy. So all financial data related to the banks, it is available on the website of RBI. At the same time, if we just see the example in our field, the researches which are related with the stock market. So the data which is related to the stock market, you can get from their respected website also, and you can get this data from the SEBI also, which is a financial market regulator. So if you are going to collect the data from these sources, so you can say that these are the authentic sources. After this, the main important thing is data analysis. And in this lecture, we are going to discuss about the data analysis. So in the data analysis, you are going to apply the technique of analysis to analyze your data. So randomly we cannot decide, but on the basis of the objective, we can see that which statistical technique is more important, and on that basis, we can decide that what technique we can apply to analyze the data. So this is also very important thing, that in the data analysis, we are going to analyze the data. At the same time, we are going to decide that in line with the objective of the research, which technique, which statistical technique or which statistical model is more appropriate to apply. Then next is interpretation of data and report. So after getting the result from the data analysis, we can make the interpretation of this result. We can prepare the report also. And at the same time, there are different structure of report. If you are going to write a dissertation, the format of report is completely different. If you are going to write a thesis, so again, thesis report, the structure may vary from university to university. If it is a kind of research paper, so again, the way of reporting is completely different. And if it is a working paper, which is sponsored by some institution, so again, the status, the structure of the report may be different. So in the report writing, again, we have to see that what are the contents. At the same time, generally, we also provided what are the limitation of the research and what is the future direction for the research. So these are the steps generally we follow in the research. In this lecture, we are going to cover the regression analysis, that how we can apply the regression in regression model to analyze the data. So in the data analysis, regression is a very important technique and it is very wider concept. Again, if we want to cover the whole concept in a one lecture, so we can say that the time is very less, but you can see that there is a complete book on this topic, that how to model or how to analyze the data with the help of regression model. So regression is something that this model is going to provide you the cause and effect relationship between or among the variables. So in the simple word, we can say that the regression model, it is something that which is going to provide you the information related to the cause and effect. Now, cause and effect, we need to understand this concept, cause and effect. Some variable is there which is causing the another variable, and the change is coming in the another variable. For example, you can see the example of price and demand. So if there is a change in the price, the effect can be seen on the demand. Okay, you can see that if any product is there, generally you are going to buy the product from the market. So if there is an increase in price, so you can see that there is a effect on the demand. If there is an increase in price, generally there is a effect on the demand. If there is a decrease in the price, there is an effect on the demand. So you can say that there is a cause and effect relationship. The price is causing the effect in the demand. Just because of the change in the price, the effect is coming in the demand. So this is one example you can consider for to understand the cause and effect relationship. Just recall the things which is related with the correlation. I think most of the participants, they are the research scholars are also there, the faculty members are also there, even some PG students are also there. So I think you have gone through the correlation concept also in the statistics. So if you recall about the correlation, so correlation generally provide the information that what is the degree of relationship between two variables. But how much changes are coming, how much changes are there, it is not going to provide you this information. Correlation generally we denote with the R, and R, for the property of R is that generally the value of the R lies between -1 to +1. -1 means perfect negative correlation, +1 means perfect positive correlation. So it is providing you the degree of correlation, it is providing you the degree of relationship. But if we want to quantify the change, okay, if we want to quantify the cause and effect relationship, we cannot do this with the help of correlation. So we can extend this, we can go to another extensible concept, which is known as a regression. And through the regression, we can quantify the cause and effect relationship. And we can see in terms of quantity that how much changes are coming just because of the one variable to the another variable. So this is a statistical technique that expresses the relationship between two or more variables in the form of equation. To estimate the value of a variable based on the given value of another variable is called as a regression analysis. The linear algebraic equation used for expressing a dependent variable in terms of independent variable is called as linear regression equation. So in the regression analysis, It may be a bivariate regression analysis. It may be a multivariate regression analysis. In the bivariate regression analysis, we are going to see the relationship of one variable with another variable. Again, you just see that cause and effect. One variable is causing the effect in the another variable. So just recall the example of demand and price. So the price is a factor. Just because of the change in the price, the effect is there on demand. So in this, we can classify the variable in dependent and independent variable. Now, where the changes are coming? The changes are coming in the price and it is causing the change in demand. So here the demand is the dependent variable and the price is the independent variable. If suppose one independent variable is there and one dependent variable is there, so the relationship, you can consider this as a bivariate relationship, or you can apply here the bivariate regression. If the factors are more, if the independent variables are more, it can be more than, so it can be more than one also. There are so many variables which can affect the demand apart from the price. Okay. For example, you can consider the income also. So if there is a change in the income, so it can affect the demand. So right now there are two variables, two independent variables which are affecting the demand. So in this case, you can go for the multivariate regression analysis. So bivariate, two variables, and multivariate where the independent variables are more than one. Now you just see this model.
Good evening, sir. Sir, actually slides are not changing.
Slides are not changing.
Yes, sir. Now it is changing.
Okay. So this is a model for the regression analysis. And in this model, you can see that the equation is y is equal to b0 plus b1 x plus e I. Here the y is the dependent variable, and we can call this as a regressant also. Then x is an independent variable, and we can call this as a regressor also. Now b0, this is known as an intercept, and b1 is known as a slope or beta, and e is the error term. So this equation is called as a econometric model, structural equation, or the regression function. Okay, y is equal to b0 plus b1 xi plus error term. If you recall the book, so maybe in the book you may find that the equation is just like this: y is equal to a plus bx. Okay, so a and b, these are the regression coefficient. Here the b0 and b1, these are the regression coefficient. So dependent variable, again, just you recall this example that we discussed. This is all about the demand and price. So we can, if we want to show this relationship in terms of the model, so we can write like this: demand is equal to intercept plus slope multiply with the price plus error term. Now there is a need to understand these terms, because if you are clear about these terms, then you can easily understand the various other things about the regression analysis. Y is a dependent variable. So just because of the independent variable, the changes are coming in the dependent variable. So in the example, the demand is the dependent variable, and we are going to estimate the demand on the basis of the other independent variables. Now constant, intercept. Intercept is something when we estimate that the all independent variables are equal to 0, then the dependent variable in this case is equal to the intercept, and that's why we call this as a constant term also. Okay, if your x is equal to 0, it means that in this case the y is equal to only b0. If we say that the price is equal to 0, in this case the demand is equal to intercept. Okay, so if the value of the independent variable is equal to 0, in this case the independent variable value is equal to constant or intercept. Slope is known as a rate of change because it is a linear relationship. So the value of slope is showing you the rate of change. Okay, value of slope is showing you the rate of change. Now, can we say that the change in the demand is coming just because of only price? because in this model, if we consider the same example, so we are saying that the y is equal to b0 plus b1 xi. So x is equal to price, y is equal to demand. And the changes are coming in the demand just because of the price. But in the reality, there are other variables also that can have the impact on the demand. So we are going to signify the relationship between only demand and price, but at the same time, there are various factors that can have the impact on demand. So that's why we are putting the error term also here, error term. Okay. Apart from the price, there are different variables that can impact the demand. So because we are not considering these variables in the model, at the same time, that's why we are putting the error term for all those variables which are not taken into consideration in the model. So this is all about the model, okay? And in order to understand the concept of regression analysis, you should be very clear about this regression equation, econometric model, or structural equation. Now, here y is there as a dependent variable. Then this b0 and b1, these are the regression coefficient. You can consider this as a b0 is equal to constant and b1 is equal to slope. X is a dependent variable and this e is a error term. Okay, you can say error term for the residual disturbances. We need to understand the nature of y and x variable. Y is a dependent variable and x is a independent variable. So first of all, we need to understand the nature of y and x variables. If we talk about the dependent variable, so yes, is there any question? Yes, practical will be there. We will go through the practical, and before practical, I think some concepts are there which need to be defined. So we have the data also, data set, and we will go for the practical also. So nature of y and x, so it is generally assumed that y is a random variable and it can be measured on the 4 different scales. And these scales are ratio scale, interval scale, ordinal scale, and the nominal scale. So I think you all are aware about this scale. Through the nominal scale, we can say we can measure the variable only in terms of name. So mathematically, we cannot do anything with this nominal scale. As far as the ordinal scale is concerned, so we can show this only in terms of ascending and descending order only. And apart from that, we cannot perform any mathematical function in this ordinal scale. Then interval scale is there and ratio scale is there. So in the interval scale, even we can arrange the data in the ascending or descending order also. And the basic difference between the ratio scale is we can even also divide. Whatever the data is there, we can also divide and we can perform all kind of mathematical function in the ratio scale. But as far as the basic difference is concerned, in the ratio scale, 0 means exactly 0. And in the interval scale, 0 is not exactly 0 means it is not exactly 0. You can consider the example of temperature in the form of, in this interval scale. So it can be measured as far as the independent variable is concerned on all kind of scale. If we talk about the x, the nature of x, that is nature of this independent variable. So in this, the regressions can also be measured on any one of the scale we have just discussed, although in many applications, the regressions are measured on the ratio and interval scale. Similarly, there are some stochastic error term, which is known as an error term and regression coefficient also. So the stochastic error term is the catch-all that includes all those variables that cannot be readily quantified. It may present the variables that cannot be included in the model for the lack of the data variability. So as we already discussed that in the model, sometimes it happens that we cannot consider the all independent variables that have the impact on the dependent variable. So these generally we put in the form of error. Regression coefficient, so this intercept and slope. So in the CLRM, classic linear regression model, it is assumed that the regression coefficients are some fixed number, are not random. Even though we do not know the actual values, it is the objective of the regression analysis to estimate their values on the basis of the sample data. if we have these regression coefficient, we can make some future prediction also about the dependent variables. So these are also very important in the regression analysis. So nature of data. In the nature of data, we have three kind of category. First is the time series data, then cross-sectional data and panel data. You can see this example here. The equation is given to you again in the form of linear regression model, where we are talking about the violent crime rate by state, and this is a dependent variable, and unemployment rate, this is the independent variable. Okay, so the equation is that the violent crime rate is equal to intercept plus beta. Here the independent variable is unemployment rate, so this unemployment rate is creating the impact on the violent crime rate. In the same case, if we are taking into consideration this data which is related to the violent crime rate and the unemployment rate only in this Alabama for different years. So this is a time series data. We are considering only 1 year 1976, and we are talking about the unemployment rate and the violent crime rate for different states like Alaska also, Arizona also, Alabama also. So this is a cross-sectional data. When we are combining this cross-section and time series, so it is now becoming the panel data. Now here you can see that the various cross-sections are also there. These states are the cross-section, Alabama, Alaska, and different states are there. These are the cross-sections. So the multiple cross-sections are there. Then multiple time series are also there, 1976, 1977, 1978, and it is creating the panel data. In the form of equation, if we are writing like this, CRRATEI, so it is representing the nature of data is cross-section. If we are writing like this, that CRRATET is equal to B0 plus B1 unrate T. Okay, so T is representing here the time series. And if we are writing IT in the equation, this is providing you the equation is equal to panel data. Now, cross-sectional and fixed effect model. In the panel data regression analysis, we need to understand the cross-sectional fixed effect. We need to understand the, if we are continuing the same example, which is related to the this violent crime rate and the unemployment rate. So there may be some other variable also which can affect the this violent crime rate. Okay. So assume the model is correctly specified in the sense that there are no other important variables affecting the crime rate in every state other than the unemployment rate. However, there may be a factor particular to the each state that affect the crime rate. In those states, for instance, some states it may have the higher incarceration rates than other. In the cross-sectional fixed effect model, we can consider the model is a time invariant with the state. Here the state are the cross-section. So we can consider this that this is a time invariant because on the basis of the time, there is a not significant change in the cross-section. Another is time fixed effect model. In this time fixed effect model, if we assume the model is correctly specified in the sense that there are no other important variables affecting the crime rate in each state other than the unemployment rate. However, the impact on the crime rate in each cross-section may differ as the unemployment rate changes each year. So, in other words, we can say that the unemployment rate affects the crime rate in every state, but the slope of the relationship differ across the state. When you are going to choose the fixed effect model and when we are going to choose the random effect model, in this we have to see that whether the cross sections are invariant, okay, or whether the time is invariant. And accordingly, we can choose the cross section effect or the time series effect. Then random effect is there. So in the random effect model, it splits the difference between the cross sectional fixed effect model and the straightforward application of OLS to the panel data. So when we will go for the practical example, in this we will try to understand that how we can use the fixed effect model result and how we can use the random effect model result and how to choose that which model out of these two is best to analyze the data. If we want to choose that whether the fixed effect model is appropriate or the random effect model is more appropriate, in this case we can go for the Hausman test, okay, in the panel regression model. And in the Hausman test, we can consider the null hypothesis as the random effect model superior to the fixed effect model. And alternative hypothesis is fixed effect model superior to the random effect model. This Hausman test, here you can see that chi-square value is also there and p-value is also there. If your level of significance is 5%, so on that basis, you can, on the basis of the p-value, you can decide whether the null hypothesis is rejected or accepted. So on that basis, you can decide that which model is. Then in this regression analysis, again, we should understand the meaning of this term robust standard error. Panel data, this is a combination of two things. One is the cross-section, another is a time series. Generally, in the cross-section, the data can suffer from the heteroscedasticity. In the time series, it can affect from the serially correlated errors. Or in the other words, we can say that the autocorrelation. So if we are using the panel data, so there is a chances that the both kind of error may exist in your model in the form of heteroscedasticity also and autocorrelation also. If we want to deal with this problem, we can go with the robust standard error, and various econometricians, they are using the robust standard error in the panel data regression. If the model suffer from either or both heteroscedasticity and autocorrelation, then the robust formula will correct the bias in the standard error of estimators. R square, so I think you all are aware about the R square. R square is the coefficient of determination. It provides you the information that the changes in the dependent variable explained by the independent variables in the model. So if the value of R square is suppose 87%, it means that the 87% changes in the dependent variable is just because of the independent variables considered in the model. Adjusted R square is also there. So if we are going to compare the two models, so in this, the adjusted R square is the best option to analyze the changes explained by the independent variables. As we are going to increase the variables in the model, so generally it increases the value of R square also. So you can say that the R square is a kind of increasing function. Okay. So generally researchers consider the adjusted R square also, and it is very important tool to compare the two models where the dependent variable is same. Assumptions of the regression analysis. So if we talk about the assumptions, there are basically four different kind of assumptions that we are going to consider. First is the multicollinearity, second is the heteroscedasticity, third is the serial correlation, and fourth category is the model specification errors. So in this multicollinearity, if you see the name, the multicollinearity means that the variables, the estimators, or you can say the regressors, they are completely linear to each other. Okay, these are completely linear to each other, and this is a situation of multicollinearity. In other words, we can say that the independent variables are highly interrelated to each other. Then second is the heteroscedasticity. Hetero means various, scedasticity means the variance. So this is a situation, heteroscedasticity, where we can say that there are unequal variance in the errors. Serial correlation, this is a situation where the terms are, the data is having the problem and they are related to their existing value. They are, you can say, previous values. For example, in our case, the stock market figures are there. So whatever the closing price of a particular stock today, it is related to its previous value, means day 1 before, day 2 before. So this is a situation of serial correlation, where the data of a one series, it is related to its existing or previous values. Then some other model specifications are also there. So multicollinearity, if you want to detect the multicollinearity, in this case, you can use the correlation matrix also. And if you are finding that the independent variable correlation, suppose two independent variables are there in the model, and the correlation between these two independent variables is coming, which is more than 70%. So it means that there is a severe multicollinearity in the data. Other measure is variance inflation factor. So you can compute the VIF also. And if the VIF generally it range from 1 to infinity. So if your VIF value, it is coming less than 10. So if it is coming if it is coming greater than 10, then the original regression suffers from the severe multicollinearity. If VIF between the 1 and 10 indicating increasing degree of multicollinearity, and it requires the auxiliary regression. Auxiliary regression means in the variance inflation factor, we are going to regress the model and we are taking the independent variable as a dependent variable. Okay, for example, the equation is just like this: y is equal to a plus bx plus cz. So this y and z, these are the independent variable. So in the auxiliary regression, we are going to consider this x and z, which are the independent variable, as a dependent variable, and we are going to create the different models to know that whether what is the level of multicollinearity in the data, and this VIF, it may be computed as 1 divided by 1 minus r square. In the heteroscedasticity, if you want to detect that whether this problem is existing in your data, again you just see that heteroscedasticity literally means different spread or different variance. Okay, it occurs when the error terms from a population regression do not all have the same variance. So same variance is a situation of homoscedasticity, and heteroscedasticity is a situation of unequal variance. So in this problem is existing in your data, so you will not get the best model. Here the best model is that can predict your dependent variable with unbiased estimators and the correct estimators. So in this case, we can use the Bruce-Pagan test also. The null hypothesis that you can consider that there is a no heteroscedasticity in the data. Alternative hypothesis you may consider as there is a thing in the data. On the basis of the result of Bruce-Pagan test, you can say, you can check that whether this problem is existing or not. Serial correlation. So the correlation with itself, this is all about the serial correlation. So we can detect the serial correlation with the help of Darwin-Watson test. And there are different ranges of the value also in the Darwin-Watson test. And if the value is near to 2, so you can consider that there is a no stationarity problem. Okay. And if the value of D is less than 2, you can suspect that there is a positive autocorrelation. And if the value of D is greater than 2, you can suspect that there is a negative autocorrelation. So Darwin-Watson test is there, which is given by the Darwin and Watson in the 1951. And apart from that, you can also go for the Lagrange multiplier test. Apart from that, there are different model specification errors are also there that may exist in your model. And in this, various other things are also there that we need to check. Like the model does not exclude any core variable. If we talk about, suppose that there is a problem of multicollinearity. So what you can do, you can either eliminate or add some more variables, independent variables in your model. But it should not change the whole model specification for which the model is framed. So in the model specification error, we should also see that the model does not exclude any core variable, which is a core function of your model. Another thing is the model does not include the superfluous variable. Sometimes if we want to include some more variables, and it may also happen that the variable which is not very related to your model, but still we are including this model. So this kind of spurious variable should not be there in your model. Third is the functional form of the model is suitably chosen. Functional form. It may be linear, it may be exponential, it may be logarithmic, it may be in terms of square, cube. So functional form, we should see that it should be suitably chosen for the model. There are no errors of measurement in the regressand and the regressor. Errors of measurement. We talked about the ratio scale, interval scale, ordinal scale. Okay. So ordinal, nominal, ratio, and interval. So it should be correctly measured in terms of data. We should see the nature of data, and accordingly we should go for the right scale of measurement. And finally, the outliers of the data. So again, outlier is something that can inflate your mean also, that can inflate your mode, median also, it can inflate your coefficient also, through which you are going to predict about your dependent variables. So you should see that whether any outlier is existing in your data or not. This is all about the numerical, this is all about the theoretical things that is very important to understand the regression analysis. And now we will see that how to go for the regression analysis with the help of software. So now you can see this Excel file.
Excel file is
And the
visible?
file is also visible?
Yes, sir, visible.
Okay. So I think the participants are there from the different disciplines. So again, what we are going to do this with this data, so we need to understand the whole concept that what it is all about, because all these are the financial terms. But first of all, we should know that what is the dependent variable in this data, what is the independent variable, how we can frame the equation, and then how we can go for the analysis. So first of all, you can see that this is a kind of panel data. So these are the sugar companies, and this is one of the paper which is going on. And this is something which is related to the relationship between the intellectual capital and the financial performance of the Indian sugar mill companies. So in this, this is a sample which is taken. Okay, you can see that the 19 companies are there. Okay, and the data is taken from 2012 to 2021 and 22. So whether my voice is coming clearly? I think I received a message in the chat that sometimes voice is breaking.
Yes, sir.
Clear.
Okay. So 19 sugar mill companies are there, and the data is collected from the secondary sources, and the study period which is considered in this data set, that is from 2012-13 to 2021-22. Okay. Again, just recall that there are three kind of nature of data, that it can be a time series data, it can be a cross-sectional data, and it can be a panel data. Cross-section data means that the time, if you are talking about the time series, so it is only one single time series. Okay, and the cross-sections are multiple. So suppose we are considering the data for all 19 companies for only 1 year, that is 2021 and 20. Only 1 year and multiple cross-section. Cross-section means companies. So it is a cross-sectional data. If the cross-section is only one and the time series is multiple, we are talking about only one company. Okay, and the time series is from 2013 to 2021 and 22. So multiple time series is there, and the cross-section is only one. So we can categorize this as a time series data. Panel data, it is a combination of both. It is a combination of both. Time here, the cross-sectional are also multiple, and the time series is also multiple. So this is a form of panel data. Okay. Now we are talking about the variables. So these are the variables. ROA stand for the return on asset. ROE stand for the return on equity. So these are the two indicators for the financial performance. So in our model, we are going to consider this as a dependent variable. These are the proxy for the dependent variable. Then,
sir, sorry for interrupt you. Sorry for interrupt you, but your voice is not clear. It's breaking, sir.
Okay, my voice is still breaking. Whether this problem is coming to all or to only one participant?
No, we can hear your voice clearly. Maybe the other participant is getting problem.
Okay. You just please check your internet connection, because other participants are saying that the voice is coming clearly. So you just please check that your internet is properly working or not.
Okay.
Okay, thank you. So in this model, now it is clear that it is a panel data. Then if we talk about the variables, so these are the variables. So you just see that we are going to measure the relationship between two things. One is the intellectual capital, and second is the firm performance. And these firms are the sugar mill companies. So ROA and ROE, return on asset and return on equity. So these are the two independent variables, and for this we will make the two different equations. In one, we will take ROA as a dependent variable. In another model, we will take the ROE as a dependent variable. So these are the proxy for the financial performance. Then HCE, SCE, RCE, and ICE. These are the component of the intellectual capital. SCE stand for the human capital efficiency. SCE stand for the structural capital efficiency. RCE stand for the relationship capital efficiency. And ICE, this is a total of all three. This is the intellectual capital efficiency. Then another component is also there, CCE. So if we add this CCE in this ICE, so we will get the modified value added intellectual capital. So this, just don't go in the technical terms, because I think if you are not from the financial background and if you are not from the commerce or economics background, so I think it is difficult to understand this, but just see that how we can make the model. We want to know the impact of intellectual capital on the firm performance. So this is a capital, current capital efficiency. If we add this in IC, we can get the MVAC. So now we can say that, now we can see that how we can frame the model out of this. We are going to make the 4 model from this. One is ROA equal to beta naught, this is the intercept, plus now we are going to start the independent variable along with the coefficient. So B1 first HCE, human capital efficiency, plus B2 is the coefficient for the second independent variable, and our second independent variable is the structural capital efficiency, plus B3 is equal to, B3 is the coefficient for RCE, this is the research capital efficiency. Okay, so these three are the component. Okay, these three are the component. In one model we can go for only component. In another model we can go for this MVAC, modified value added intellectual capital. Okay, so if we will add all the component, we can get the value of modified value added intellectual capital. So considering only components, there is no need to include this MVAC. Here in this model, we can consider all the components as a dependent variable. Another is CCE. Now control variables. There are some firm specific variables are there. So we need to control the model while adding the control variable in this model. Control variables are leverage. So next is B5. Leverage. Then another control variable is size. So total asset, it is through the total asset we can measure the size. Plus our next coefficient is B7, and this is for any company which started in 2001. Okay, and we are considering the data for 2021-22. So by 21-22, the age of the company is 21 year or 20 year like this. So this is the age of the company. It can also affect the financial performance. So the model, we are controlling this model while adding the control variable in this model, leverage, size, and age. These are the control variable. Component SCE, SCE, RCE, CCE. These are the component of the intellectual capital. So this is one model. Then finally we can add here the error term. Second model, the same model we can consider, and we can change the ROA with ROE. In order to know that what is the impact of the intellectual capital on the firm performance, at one time we are considering the ROA as a proxy of the financial performance, return on asset. Another time we are considering the return on equity, okay, to know the impact of intellectual capital on the financial performance. One time we can consider only components. Second time we can consider the modified value added intellectual capital. So ROA is equal to B naught. We are not considering the components, we are directly considering the modified value added intellectual capital, then control variables. So these are the control variables. Coefficients are B1, B2, B3, B4. And one time we are considering the ROA as a proxy of the financial performance. Another time we can consider the ROE, return on equity, as a proxy of financial performance. So our models are ready. Okay. Our data is also ready. Now equations are very clear to us, and we can export this data. In order to go for the panel regression, you can go through with the help of Stata also. You can also run this with the help of eViews, and you can also run this with the help of R software. So various software statistical packages are also there through which you can run the regression. If you are having the time series data and you want to run the regression, so the same you can run with the help of SPSS also. Okay, in the various advanced version of SPSS, this option is available for the panel regression. But generally, if you are having a nature of data as a time series, so you can go for the regression with the help of SPSS also. For the time series data, the regression option is also available in the Excel. So in the add-in, you can add in one data analysis tab in your Excel, and you can go for you just define that this is a dependent variable, this is a independent variable, and directly you can go for the regression result. Other Stata is there, R software is there, eViews is there, so you can use these software to run the regression analysis. Right now, we are going to demonstrate the regression analysis with the help of eViews. Copy is available on this website, eViews, so you can go for the student copy. In the financial econometrics, we are widely using this eViews because so many financial techniques, statistical techniques are available in this eViews. So you can download the eViews also from the website, and you can run the various analysis technique. When we are clicking on this eViews after the installation, so this is a eViews 10, and for most of the version, this window is just like this. There are options: create a new eViews work file, open an existing eViews work file, or open a foreign file. Okay, so you can click on this, open a foreign file. This file is there on desktop, and the folder is created MTTF. Okay, sugar mill data. You can select the file. Right now, it is asking you the data is in the process of export, and it is importing through the eViews. So you can go for next. It is because your data already in the form of panel. So if you are just making a panel, so you should be very clear that in the Excel file, when you are in the data, so it's in the form of panel. Now, how it is in the panel? We are first of all starting with the cross section. Then we are coming to the time series, and then the data is there related to various variables. You can see that 19 companies are there, and it is systematically designed. Okay, this one, for example, first company, we are having the data for 12/13 to 2021. 21-22. Similarly, for second company, we are having the data for 2012 to 2021-22. When you will export this file to the eViews, so similarly, it will consider the cross section also, time series also. You can go for next, then again next. Undated panel, finished. Now your data is ready for making the analysis while using the Excel. Now your data is ready. What we can do with this data, and what we can do with this data. So variables are defined, model is defined. If you are aware about the models, then you can better than this software. Software is not going to tell you anything. This is the very first thing. Researcher should know that how he or she is going to deal with the data. eViews or any other software, it will not tell you that what is the dependent variable, what is the independent variable, what is your model. Ultimately, as a researcher, you have to define that what the model is all about, what you want to do, what is your objective of research, and in the line of the objective, how you can frame your model, how you can frame your hypothesis, and how you can go for the analysis. Okay, whatever the command you will give, accordingly the software will give you the result. Okay, for example, we use one term during the discussion, that is spurious correlation. So spurious correlation is something that two things, if they are exactly related to each other, somewhere they are related to each other, so making the analysis will make some sense. But two things which are not related to each other, okay, not related to each other, we are going to compute the correlation. So definitely while applying the formula or while using the software, we will have the value will be there, but there is no sense to make the interpretation of this value. If I want to see that that how many number of chairs are there in the university and how many number of students are there in the university. So exactly there is no relationship between this, that number of students admitting in the university and number of chairs in the university. There's no sense to making this relationship, but if we are having the data, we can run the correlation and we can get some result. And on that basis, you can make the interpretation also. But there's no sense for making this kind of analysis. If we are saying that demand and price, so theoretically, these two things are related to each other. Conceptually, these are related to each other. So that will make some sense that if we will analyze this with the help of correlation regression, and then we can make the interpretation. We want to see the descriptive statistics for this. So this descriptive statistics option is there. You can go for the individual sample and then you can write your variables. For example, ROA, ROE. These are the two dependent variables that we are considering. Then human capital efficiency, RCE, structural capital efficiency, ICE, MVAIC, leverage, size, age. If you want to descriptive statistics for these variables, we can put the name as we provided them in the data sheet. Okay, we can press OK and we can get the descriptive statistics for the variables. If you want to check the correlation, take on quick, go to the group statistics, correlation option is there. Again, just write the name that you want the correlation matrix. Okay, so you can go for ROA, ROE, another variable SCE, then structural capital efficiency, RCE, then CCE, ICE, leverage, age, size. Okay, so variables, we need to put the name, and if we press OK, leverage is not correctly right. Group statistics, go for correlation, write once again ROA, ROE, human capital efficiency, structural capital efficiency, ICE, leverage, age, size. You can write all the names of your variables, press OK, and then you can get the correlation matrix, and it is showing you the result for the correlation between the various variables. Through this, you can check the correlation between the ROA and ROE, ROA and SCE, ROA and SDE, ICE. How many variables are there in a model? So you can check the correlation between each and every model, two models. So this is how you can go for the correlation matrix. Through the correlation matrix, as I already told you, that if you want to diagnose the multicollinearity, okay, whether your independent variables are highly related to each other or not. If these are highly related to each other, it means that it is creating the problem of multicollinearity. So if you are finding the correlation between the two independent variables which are coming more than 0.70 or more than 70%, so it means that there is a situation of severe multicollinearity problem. So with the help of this correlation matrix, you can see that whether this multicollinearity problem is coming in your model or not. Okay, and as far as the remedial action is concerned about the multicollinearity, so even you can go for the principal component, or you can go for the computing the ratios also, because sometimes when we are computing the ratio, so with the help of ratio, we are going to express the two variables. And you can go for the differences also. Then next, we want to check the normality of the data. So for this, you can go for quick. You can go for the estimate equation. When you are going to estimate the equation, so you can write like this. Just see the model that we created. Suppose if you want to see this for the third model where the ROA is the dependent variable.
Wala bhangi ni. La ilaha illallah. Wala bhangi. Ya na hala nan kasar hamma majin bari hala nan.
I think some mic is on there, so please unmute your mic.
Fi sabilillah. wani da wani antika na wani kala kala ya mana zo gujin da ma are awun duri patoro zuzin sa ganya are yo dole wanzu da kuma are
Please
ngila
unmute your mic. So suppose if you want to test we want to check the normality of the data. So if you want to do this for the third model, so we are going to check the normality for the third model. So in this, we just should go for the E-views, and in this we can go for the equation estimation. We can write the equation ROA, then C. C is for the constant. So when you are writing the equation after the dependent variable, there is a need to write the C when you are writing the equation in the E-views. ROA, then your next independent variable is MBEC, then control variable, leverage, age, and size. Press OK. Then go for view, residual diagnostic, come for histogram normality test, and through this you can check the normality of data. So this histogram is there in front of you, and through this you can check that whether your data is normally distributed or not. The mean is also given there for 1190 for sample of 19 companies for 10 years. Observations are 190. And through this probability value, you can know that whether your data is normally distributed or not. The p-value for the Jarquera is given as 0.00. And in this, you can consider the null hypothesis as there is a no normal distribution, and the alternate hypothesis is that there is a normal distribution. So your p-value is saying that you can go for the rejection of the null hypothesis and you can accept the alternate hypothesis. Then after the descriptive statistics, checking the normality of the data and the correlation matrix, again you can check.
Can I ask a question, please?
Yes.
Yeah, just now you said about Jarquera test. The null is normal or the null is non-normal?
Here the hypothesis, null hypothesis is that there is a no normal distribution. And alternative hypothesis is that there is a normal distribution, normally distributed data. If your level of significance is 5%, just please listen.
I understand. So in this case, you mean to say that this distribution is normal. But if you look at the skewness and the kurtosis, I think inference is looking slightly other way around. Because that is another way to look at the normality is you look at the skewness and just to
Okay. So if you are going to define the normality, so the normality can be defined in terms of histogram also. With the help of skewness and kurtosis, again you can check that how it is skewed, positively skewed, or right side is skewed or left side is skewed. For defining the normality, there are different kind of other tests also. For example, in the SPSS, you can find the Shapiro-Wilkinson test. So because the skewness and kurtosis, there are some ranges which are given in the skewness and kurtosis, and according to the range, we generally define that whether the data is normally distributed or not. But on the basis of observation also, there are some other tests also like Shapiro-Wilkinson test, Kolmogorov and KS test. This is S stand for Shapiro, like this. So in this test, if you are going to apply the test, again on the basis of the p-value, you can define that whether your data is normally distributed or not. If you are going to consider the level of significance as a 5%, okay? So on the basis of 5%, if your p-value which is coming less than 0.05, so in this case, you are going to reject your null hypothesis. And if your p-value which is greater than 0.05, so in this case, you are going to accept your null hypothesis. So on that basis also, we can decide that whether the data is normally distributed or not.
Okay, sir, let us assume that the residuals which you are testing comes to be non-normal. In that case, what are the adjustments that can be done so that we get a more robust result?
Yeah, this is also a very good question, that if your data is not normally distributed, so if suppose we are going to do the diagnostic, so what are the remedial for dealing with the abnormal data? The data is not normally distributed. In this case, first of all, you can see that whether any outlier is there in the data series or not. Because suppose if we are talking about the profitability of the firm, so suppose we are having the 10-year data and all the values which are coming from 10,000 to suppose 20,000. But in one particular year, the observation is coming just like 95,000. So you can see that this observation is going to inflate the mean also, and this observation is going to inflate the other measurement of central tendency also. In this case, presence of this outlier, that will definitely affect your mean. And if you are going for the advanced analysis, so because in this regression, the regression coefficients are going to play a very important role for the future estimation. Presence of outlier may also inflate this regression coefficient also. So first of all, there's a need to see that whether the outlier is there or not. Still, if you are finding that the outlier is not there, but still your data is not coming normal, in this case, you can go for transformation. Okay, transformation of data is there, and you can go for the log. You can take the log for the variable. You can go for the lag also for first difference or second difference, and then again you can further apply to make your data normal if it is not coming. Okay, can we proceed further?
Yeah. Sir, just one more question comes to my mind. Normally, when we are handling time series data, we tend to find out the stationarity. Whether the normal most popular happens to be the augmented decupular test. But when we are doing a panel data, which is basically a combination of cross-sectional and time series, is stationarity test very important, or we can skip it?
Stationarity test is important when we talk about in the presentation slides. So the serial correlation is again very big assumption. There should not be a serial correlation again that will inflate your coefficients. Okay, so there's a need to check the stationarity. You can go to find out the serial correlation, and it should not there should not be autocorrelation in your panel data series.
Okay, sir, can you just show me at least for one case, how do we really try to find out a stationarity and try to interpret?
Yes, I think if you have any questions, so when we will finish the session, at that time you can ask the question, because some tests are also there, and we need to fulfill all the assumptions, then finally we can go for regression analysis.
Thank you.
Yeah, any query will be there. I think your query will be fulfilled when we will go for the further assumption test.
Sir, box plot is also a we can check from that box plot, sir.
Yes, we can check.
Okay, sir. Thank you.
Okay. Okay, so this is all about the normality of the data. So first we already discussed about the multicollinearity. Okay, then normality. Then next thing is the heteroscedasticity. So in the heteroscedasticity, we are talking about the unequal variances in the error terms. So we are going to regress the equation on the basis of errors. Here we are considering the error as a dependent variable. Okay, and we need to see the impact of this error term square on the other. So this is a very severe problem in your regression model, in your panel data. If the heteroscedasticity problem is there, so definitely it will inflate or it will affect your regression coefficient. And through the regression coefficient, you cannot predict for the future about the dependent variable. So how to know that whether in your data the heteroscedasticity problem is there or not? So in this case, again we can go for quick. Then we can go for the estimation of equation. We can write our model here. Model is ROA, then C, then back, then our control variable, leverage, age, and size. Okay, this is the model. We are going to get the result. Then we can go for the view. Residual diagnostic. At last, the heteroscedasticity test is there. Okay. So in order to detect that whether the heteroscedasticity problem is there in your panel data or not, you can go for this result, which is the result of for the detection of the heteroscedasticity problem in your data. Again, you can see that null hypothesis residuals are homoscedastic. Okay, null hypothesis is null are homoscedastic. In this case also, this is a result of Bruce-Pagan test in the EVUs, and the probability value you can see here, it is coming 0.000. So again, it is indicating that there is a rejection of the null hypothesis. And null hypothesis in this case is that there is a no heteroscedasticity problem in your data. And alternative hypothesis is that there is a heteroscedasticity problem is existing in your data. So on that basis, you can see that there is a rejection of the null hypothesis. While diagnosing the heteroscedasticity problem in your data, again, we have to see that what are the remedial steps. In terms of the remedial step, we can go for the weighted least square that will provide you the equal weight of the observation in the model, or you can go for the dynamic panel regression. In this case, there are two kinds of different regression. One is static, which is applicable for the static panel. Another is the dynamic. So if you are finding that there is a problem of heteroscedasticity of data in your model, so in that case, either you can go for the weighted least square method, or you can go for the dynamic panel. In the dynamic, generally this problem happens when there is a two-way impact in the equation. Two-way impact is like we started with the example of demand and price. So in the demand on price, what we are saying that the price is an independent variable and it is impacting the demand. At the same time, it may also happen that the demand is also impacting the price. When there is a change in the demand, there is a change in the price. So at the same time, both variables are working as a dependent variable in one situation, and in another situation, both variables are working as an independent variable. Price is also affecting the demand is also affecting the price. So there's a two-way relationship. So generally, in this kind of case, the situation of heteroscedasticity problem is there, and in order to deal with this, we can go for the GMM. Then we want to check the serial correlation or stationarity. So for checking the stationarity for the time series data, the different kind of options are there, as it is discussed by the one participant also. In the panel data, we can go for the Darwin-Watson test, and through the Darwin-Watson test, we can see that whether the problem of stationarity is there or not in the data. Again, there's a need to understand the serial correlation or autocorrelation. Autocorrelation means the correlation with itself. Means the correlation is there and it is with itself. For example, stock market. For stock price, there are one stock for Reliance Industries, and closing prices are there for different days. So in the autocorrelation, there is a correlation of this stock price of Reliance Industries with its previous values, and it is known as autocorrelation. So if we talk about the assumption of the regression, so the autocorrelation should not exist in the data. Otherwise, the coefficient through which we are going to predict the dependent variable for the future, that will be biased in the nature. So in order to detect the serial correlation, one thing is we can go for the correlation matrix. Another thing is we can check the serial correlation with the help of Darwin-Watson test. If the value is near to 2, then you can say that there is no autocorrelation in the data. Autocorrelation problem is not there. And if it is exceeding 2 or it is less than 2, then in that case, there is some degree on the basis of the value we can define which in terms of autocorrelation. Finally, we can go for the result also for the regression analysis. Again, we can go for quick, then we can go for the estimate equation. And again, you can write the equation rho is C, then your variable is modified value added intellectual capital, then leverage, age, and size. So these are the control variable. You want to apply the regression analysis for this. Then you will go for the panel option. So if your panel is balanced in nature, okay, and it is correctly export to the e-views, in that case you will find this option. Again, I think the mic is on from some participant side. Please unmute your mic. Okay, so when your data is correctly exported to the this e-views, so in this case you will find this panel option, and you have to decide on the basis of your data that cross-section effect, effect specification. So if the fixed cross-section effect is there, then you can consider the fixed. If the random cross-section effect is there, then you can go for the selection of random. If you want to know the result for the fixed effect model, okay, so just select fixed, press OK. Here you are getting the result for the fixed effect model. Here the dependent variable is ROA, the complete summary is coming in front of you. The method is the panel least square. Okay, sample observation is 1 to 190. Panel period included 10, that is for the time series. Cross sections are 90, and total panel observation is 190. Our variables are given there. C stand for this constant. Then MVAC, leverage, age, size, these are the independent variable and the control variables. For every variable, the coefficients are given to you. Generally, when we are starting with the equation, when we are going to fix the model, okay, we need to define that what the theory is saying. Okay, what the theory is saying, what the concept is saying. For example, if we are going to enhance the intellectual capital in the firm, so definitely it will affect the profitability. But in what way? In inverse way or in a positive way? In positive sense or negative sense? So it is all about the expected relationship. Expected relationship means that MVAC is having the impact on ROA. What is the expected relationship? Expected relationship is positive. If the MVAC will increase, the profitability will also increase. If the MVAC will decrease, the financial performance will also decrease. So the expected sign is positive. What is coming in the result? You can see that the coefficient sign is positive. One side, there is an expected relationship, another side, there is an actual relationship. So the actual relationship is also coming positive, and you can see with the help of this coefficient. Standard error value is there for every variable. If you divide the coefficient with the standard error, you will get the statistic. Okay, and for 5% level of significance, if your level of significance is 5%, you are getting the p-value also for this variable. The coefficient is showing that the MVAC is positively related with the financial performance, but this is not significant because your value of p-value for this coefficient is coming 0.94, which is greater than 0.05. In this case, the size is negatively and significantly contributing towards the financial performance. And if you talk about the other factors, so apart from size, the age, leverage, and MVAC, these are insignificant variables. Relationship, you can see this from the sign of the coefficient. The probability value is telling you that whether your variable is significant or not. Just see the other side of the result also. So here the R square value is given to you, and in your model, independent variables are going to explain how much percentage. So this model, the independent variable, 36% changes in the dependent variable is explained by the independent variable. Then F statistics probability value is given to, also given, this is coming 0.00. So on combined basis, whether your model is best fit to explain the dependent variable, you can get this interpretation from this probability F statistics because it is significant. So you can see that the model is the best fit. Darwin-Watson value is also coming here, that is 1.54, through which you can decide that whether this stationarity problem is there in your data or not. If it is 32 or near to 2, you can say that there is no problem of stationarity. Okay, and if it is very far away from 2, so there is a problem which is existing in terms of stationarity. Similarly, we can go for the random effect model also, and instead of fixed, we can select the random effect model. So here you are getting the result for the random effect model. Okay, so again, you can see that the no variable is coming significant, as we can see the p-value, and the coefficients are also there for the model. If you want to put this result in terms of model, we can put, we just see the equation. RO is equal to B0. B0 is, B0 is coefficient. Coefficient is 0.21. You can write here, this is 0.21. Then m back. What is the coefficient for m back? This is minus 0.000. So sign may be changed, and the estimated equation, this is 0.00 m back. This definitely it will become 0. B2 coefficient for leverage. So again, this is 0.0002. So you can write here 0.0002. Here also this is 0.201. These are the coefficient value for the independent variables. Then for size, it is 0.008. This is minus 0.008, then 8, 0.076, 0.076. This is also minus. Okay, so now the equation is there in front of you on the basis of actual coefficient. So first of all, in the result, you can make the comparison between the expected and the actual. Second, on the basis of this result, equation is formed, and if you have the values of m back, leverage, size, and age, so on the basis of this coefficient and independent variable values, you can predict and make the estimation about the future. Now, on the basis of Hausman test, you can decide that which model is best for you, which model is appropriate for you. So for this, there is a Hausman test, and Hausman test help you to decide that whether the fixed effect model is appropriate for you or the random effect model is appropriate for you. In this case, again, you can go for the view and then come to the fixed random effect testing and go for this Hausman test. So for the Hausman test, the null hypothesis is that the random effect model is superior to the fixed effect model. This is your null hypothesis. Alternate hypothesis is that the fixed effect model is more appropriate. Okay, null hypothesis is that the random effect model is best, and alternate hypothesis is that the fixed effect model is best or appropriate to interpret the result. Here in the Hausman test, you can see that the probability value for the cross-section random, okay, chi-square statistics is given to you, that is 54.67, and the probability value is 0.00. It is indicating that the null hypothesis is rejected in this case and alternate hypothesis is accepted. So in this case, the fixed effect model is more appropriate as compared to the random effect model. So you can go for the interpretation for the fixed effect model rather than a random effect model. So through the Hausman test, we can decide that which effect random effect model is more appropriate or the fixed effect model is more appropriate. Okay, so this is all about the practical aspect of the regression analysis. And this data sheet, I will share this data sheet with you. So even you can go for run for the regression through the e-views. You can download the e-views also. And if you have any query or any question, so the session is open for you.
So my question is that while we run this regression in SPSS and we could not write equation into that. So I think that will be more user friendly compared to this e-views. Is it so, sir?
Panel, as I already told you, that if you are having the time series data, so you can run the regression with the help of SPSS. In the SPSS, the window will ask which is your dependent variable, which one is your independent variable. So you can select the dependent variable, independent variable, and then you can click on OK. So it will give you the result. But this is only applicable to time series data. For analyzing the panel data, I think the option is not available in the SPSS. Maybe some advanced version in the form of SPSS 32 or 30, it may provide you the option of panel data regression. But in the old version, only time series data you can analyze with the help of regression.
Okay, sir.
This kind of option is not there that you need to write the equation. You just select your dependent variable and select your independent variables. Any other question? Because right now you are observing that how we can do, how we can run the regression with the help of e-views. I will share the data set with you. So when you will go for the hands-on practice on this data set, okay, the recording will be there. So maybe you will find some, maybe you will have some queries. So anytime the email ID is there, contact number is there, you can be in touch. And if you are finding any problem related to the run of regression analysis with the help of e-views, you can ask.
Yes,
Dear
anybody?
participant, if you have any more question, please.
Hello.
I hope.
Anybody who want to ask any question?
Hello.
Yes, please, Tijani Adam, you can unmute your mic. Yes.
Okay, thank you very much, sir. This is a very educative session, and I think on the first day I talk about the material or the presentations. Maybe can we have the presentation so that it can guide us in the further researches and this thing?
Sir, I have a question. Hello.
Okay.
Hello.
Hello, Dr. Anuradha, please.
Yes, sir.
ask
Yes,
the
sir. Sir, I have a question that I you said about the OLS assumptions. There is a 5 assumption of the OLS model. Out of that, one assumption is there the data should be stationary. Hello.
Stationarity. Okay.
Haan ji, data should be stationarity, and for that we use a unit root test, augmented decay fuller unit root test is the reviews. If we have a suppose if we have a 4 to 5 variables, and out of these variables one variable is found to be stationarity at second difference only, not only at the level or at the first difference, it is found stationary to be at the second level only, then what kind of model we can use in this?
Okay, if the stationarity problem is there, so in case of this, if the stationarity problem is existing in your data, so definitely your estimator will not be the best estimator to predict about the dependent variable. So
Yeah.
definitely in this case, the model will be biased in nature. So if this problem is existing, in that case, either you can go for lag, and lag you can go for first difference. In second difference, again the same problem is coming. So in that case, you can go for transformation also. You can use apart from lag the other transformation component to transform your data, and then again you can check.
Sir, I found a problem with the variable total renewable energy. At the total renewable energy, I was working for the India, and in that variable, I found the problem of the stationarity. As I have only 3 variables, out of these 3 variables, 2 variables are found to be stationarity at the first difference, but the TRE, that is the total renewable energy, is not found to be stationarity as level or the first difference. It is stationarity only at second difference. So as we know that when variables are stationarity at 0 or at the first difference, then we can use the ARDL model or other model. But at the second difference, is there any model that we can use in this directly?
In the first difference, for example, if you are starting in the model with the 5 or 6 variables, so in first difference, suppose you are getting 4 data which is not coming in stationary. This stationarity problem is not coming in case of 4. So you are remaining with 2. So you can go for the second difference also. Still, if this problem is existing in your data, so again the another mode is there, that you can go for the transformation. So you can go for the transformation with the help of lag, or with the help of square or square root, okay, with the help of cube. So these measures you can adopt, and then you can again check that whether this problem is existing or not.
Okay, so
You can
apart
go for
from
the
the
reciprocal also.
so apart from the transformation, is there any another way, like ARDL model is applied in case of the stationarity at the
So
variable at the 0 level?
for the second difference, the different tests are also there to check the stationarity.
Okay,
You
sir.
are naming this model also, but you can apply these model also.
Okay, okay. Thanks. Sir, one confusion is there. If we have a panel data and we are running the random effect model or the fixed effect model, in this case, we need to run this unit root test or not? Is it required to check the stationarity in the panel data also?
This is not applicable for the panel data. Actually, the assumption tests are different for
Sorry, sir, you are not clearly audible. Sorry, sir, your voice is not clear.
Your mic is not properly connected. Voice is not audible to the participant.
Am I audible right now?
Yes,
Yes,
sir. Yes,
sir.
sir. Now.
Okay. Actually, first of all, there is a need to see that of data, whether it is a cross-section data, or whether it is a time series data, or whether there is a panel data. For
Okay.
every classification, the nature of test is also different. For example, if you want to check the stationarity, for time series, the different tests are there. For panel data, the different tests are there. Okay, so first
Sir,
of all,
I'm just asking that for the panel data, when we are running the fixed effect model or the random effect model, does we require to run the unit root test, or is it not required in this case?
unit root test.
Yes, sir. Panel unit root test is required in this case or not?
In the panel data, it is not required.
Okay, sir. Okay. Okay, thank you, sir.
Okay, thank you. Hello. I think Farhana, your voice is not clear.
Hello, sir.
Yes, please put
Hello.
your question.
Okay, sir. So I have a different sets of respondents, 5 respondents, but all the respondents, I have to prepare a different questionnaire for each set of respondents. But some of the variables are common in some of the respondents, set of respondents questionnaire. So which kind of analysis has to be done in this case?
You are saying that 5 set of questionnaires are there.
Yes, sir.
Okay, and some variables are common.
Yes, sir.
Okay, so I think these 5 set of questionnaires are prepared by you in the light of different objective.
Yes, sir.
So if the objectives are different, questionnaires are different, so definitely you will make different models.
Okay.
As I already showed you that 4 models were there. So for every model, we have to analyze the data separately. So in this case, I think because if you are having a different objectives also, different questionnaire also, so it doesn't mean that the variables are common, but model wise, you have to analyze the data.
Okay, so I have to evaluate the data based on the objective.
First of all, you have to make the equation. Okay, you have
sir.
to recognize that which one is your dependent variable, which one is your independent variables. Accordingly, you have to make your equation. And on the basis of that equation, you can go for the analysis. You can run the regression. There is a situation that suppose you are having 4 models, and in these all, for example, you just see that the control variables are common in every model. We are having 4 different equations, and in these equations, the leverage, size, and age, these 3 variables are common in each case. Okay, but still we are having 4 different equations, so we have to test this separately.
Okay, sir. Thank you.
Welcome. Any other question? Okay, thank you, sir. Thank you for inviting me for this session. This is a wonderful session, and discussion was made by the participants, and it shows that participants were very active during the session, and I hope that this will help you also in the future.
Thank you, sir, for your valuable time, and the content which presented during this session are really very helpful, informative, knowledgeable to all the participants for their research work also. And questions of related to this session has been discussed properly. Sometimes if you have more questions, you can put in the feedback form also. And the content which has been presented will be available on WhatsApp or the account where you have registered. If you have more questions or queries related to the ongoing faculty development program, please always feel free to contact us. WhatsApp is there, and you can personally contact me. My number is 919780920053. Most of the informations which you are getting in the WhatsApp are shared by me. So I think all of you have my contact number, and also in future also you want to contact to our today's resource person, Dr. Dhanraj Sharma. We will provide his contact detail, and also you can visit on the website of Central University of Punjab. From that place, you can easily access contact number, email address, what you need. So for the today's session, dear professor, this is the token of appreciation to Dr. Dhanraj Sharma, Department of Financial Administration, Central University of Punjab, Batinda, is acknowledged and honored for his explanatory contribution is the keynote speaker on data analysis, social science, and humanities research at the International Faculty Development Program on Advanced Research Methodology for Social Science and Humanities, held from January 17 to 30, 2024. This program is jointly organized by the Sardar Patel University, Vallabh Vidyanagar, India, Purnima University, Jaipur, City University, Punjab, Nexus University, South Africa, English Language Teachers Association of India, and Mathematic Thinking Foundation. Tomorrow we will join the meeting at the same time. As usual, we have, according to Indian Standard Time, we have 1 p.m. or 13:00 IST. So wait, all the information, if there is any kind of change, we will share with you. And I hope that for the today's we have to immediately change the time due to some reason. We regret the same. Thank you for being part of this ongoing faculty development program. Thank you very much. Feedback form also has been shared in the WhatsApp. Please submit your feedback, and also assignment will be there in the WhatsApp group. Please check WhatsApp group as well as your chat. Sorry, in the chat I am not able to share. Yes, you can check in the chat box also. In the chat I have shared the feedback form, and also you can check in the WhatsApp group. I am sharing there. Thank you very much for today's session, and we are very eager to see you tomorrow at the same time. Thank you very much. Thank you to all.
Thank you, sir. Thank you, sir.
Thank you.
I hope the material will be shared for us.